Hi, so today we'll look at solving limits at infinity and some shortcuts in handling these problems. So we have here limits as x approaches infinity, positive infinity, of 3x squared plus 3x plus 2 all over x cubed plus 7x. So you're given a rational function here, so you have a polynomial all over another polynomial. So how do we solve this? The first thing that we need to know is find the degree at your denominator. So the highest degree, the highest exponent here is x cubed. Okay, so after knowing that, we have to divide every single term to x cubed. So let's try that. So that will be 3x squared all over x cubed plus 3x all over x cubed plus 2 all over x cubed all over x cubed all over x cubed plus 7x all over x cubed. And then, so the result here is like 3 over x. This one is, sorry, so this one is 3 over x plus 3 over x squared plus 2 over x cubed. Okay, and then all over, this will be 1 plus 7x over x cubed is 7 all over x squared. Okay, so let's try looking at this one first. Imagine x. If we substitute 1 to x, it will be 3 over 1, right? If we substitute, then this one is saying that what's the value of this function as x approaches positive infinity? So we try to increase x. What if x becomes 10? Then the value of 3 over x is 3 over 10, which is 0.3. So that's like from 3 to 0.3. It's getting smaller, right? And then what if we try to substitute x with 1000? It's like 3 over 1000. So this one, as you can see, becomes smaller and smaller. So it is approaching what? 0, right? So 3 over, like 3 divided by 1 million, it's almost 0, right? It approaches 0. So the behavior of 3 over x is 0. Same thing with 3 over x squared. As you approaches a bigger number here, 3 over x squared also approaches 0. Same with 2 over x cubed. It approaches 0. Thus, we can assume here that the numerator is approaching 0. And whatever value we have here, okay, it's 1 plus, I think this one will, we will all agree that it will approach 0. It's like 1 plus 0. Thus, the limit of x as it approaches infinity for this equation is 0. Okay, so let's try another example. So let's try having limit of x as it approaches negative infinity. Okay, and then the value would be x to the 4 plus x all over 5x cubed plus 7. Okay, so what's the first step? You try to look for the degree of your denominator, which is the highest exponent here, 3. Okay, this one. Thus, we divide everything by x cubed. So it's x to the 4 all over x cubed plus x all over x cubed all over 5x cubed all over x cubed plus 7 all over x cubed. So evaluating this one, we will have x over 1 plus 1 over x squared all over 5 over 1 plus 7x cubed. So as the example before this, we can assume that this one and this one will behave as it approaches 0. Okay, so we can disregard this. Next, 5 over 1 is just 5, so we have 5 in our denominator. Here it's x over 1. So how can we imagine x as it approaches negative infinity? Okay, so negative infinity, it's like, for example, you have negative 1, and then you will go to negative 10, and then negative 100 for your x, and then until you have negative 1 million. Okay, so we can all agree that if you increases x, if you approaches negative infinity here in x, so if we substitute negative 1 here, this will become negative 1. If we substitute negative 10 here, this one will be negative 10. Substitute negative 100, x will be negative 100. Thus, this particular equation, if we substitute negative infinity to x, it will just go or behave like negative infinity. Okay, so negative infinity over 5, which is our denominator, will result to negative infinity. Thus, the answer for this one is negative infinity. Okay, so this is the basic way of solving for limits at infinity. So let's try to look at some strategies. Okay, so one strategy is we look at the degree of the numerator and the denominator. So if the degree of the numerator is equal to the degree of the denominator, then the answer is the coefficient. Okay, so what do I mean by that one? For example, we have limits as x approaches infinity. So it's either positive or negative infinity, whatever the equation is. Whatever you're trying to look for. So for example, we have 4x to the 10 plus 1000x to the 8, something like that, divide by 5x to the 10 plus 4. If we have something like that, can we see that the degree of the denominator is equal to the numerator? Yes, we have 10 here, 10 here. So we get the coefficient of those. So here the coefficient of x to the 10 is 4, and the coefficient of x to the 10 is 5. Therefore, the limit is just 4 over 5. It's that simple, right? So that's the first technique. If we have the degree of the numerator equal to the degree of the denominator. Okay, so let's try another one. If the degree of the numerator is less than the degree of our denominator, therefore the limit is 0. So let's try. If we have 3x to the 7 all over 5x to the 8 plus 10x plus 2, if we can see here that the denominator has a greater degree than the numerator, then we can conclude that this one has a value of 0 as limit x approaches positive or negative infinity. Whichever the case is, the limit will always be, the answer will always be 0. Okay, so that's the second technique. The first technique is the degree is equal for the numerator and denominator. The second one is the numerator is less than the denominator. And lastly, okay, is if the degree of the numerator is greater than the degree of the denominator. Okay, so if that's the case, then it's either positive infinity or negative infinity. So on this third scenario, you have to think here. So for example, we are given the limit as x approaches positive infinity. Then if it's x to the 4 all over x cubed plus 5, then this one would be, if it's a positive infinity, here it's even, so we have positive infinity. Okay, so the degree of the numerator is greater than the degree of the denominator, then it's positive infinity. Okay, so let's try another example here. So what if you try to compute for limit as x approaches negative infinity? So for this one, since we can check the highest term here, so it's x to the 4 or x cubed, this will be giving us x. Thus, if we substitute negative infinity to x, it will just give us negative infinity. So let's try another example here for variations. So if we have limit as x approaches infinity of, for example, x to the 7 all over x to the 4 plus 5, then we can evaluate this by finding the difference between the two of them. So it's x to the 7 and x to the 4. This will be giving us x cubed, and then substituting positive infinity to x cubed will just give us x positive infinity. So the answer here is positive infinity. However, if we use negative infinity here, then if we substitute any number and cube it, it will just be, for example, negative 1 will be negative 1. If we have negative 2, it will be negative 8, right? So the answer for this one, if we use negative infinity, is negative infinity. So for the degree where the numerator is greater than the denominator, you have to do a bit of analyzing and just using the leading terms here. Okay, so I hope we understand now how to compute for the limits of at infinity. Thank you and God bless.